Is an update. Still continuing work on the Hive implementation. It's taking me more time than expected because I have to write the bundler specification and ran into certain dependency issues over various projects because the Hive is pretty much very tightly tailor-made for Ethereum specific development. So I had to redo quite a bit, and I'm still progressing on that front. Also, I was given to understand that the Cilius team completed their implementation, but we ran into certain interoperability issues by with Cilius client not being able to talk to Skanda properly. There were certain issues that we were facing, and I understand from Sharif as well that apparently the snappy compression on Skanda's implementation is not working correctly. So I'd have to go back and investigate what's the issue there. So these are issues that have come up now, and it's good. We can now start to address all the interoperability problems. So yeah, Sheriff and others, if you want to give an update, and then we can probably discuss on Dan's points about the comments of the spec.
We I believe we are almost finished with the B2B part. We started testing with Scanda. I think we are almost finished with the B2B part. We still have some more to do to integrate with the other part of the bundle. Yeah.
Okay, thank you. Will, anything from your side? Sorry, Will, did you hear us?
Me? Oh, sorry. Can you hear me?
Yeah.
Oh, okay. I was testing the B2B spec with the Etherspot team. I found some protocol ID issues and we resolved that. And I'm currently working on testing it locally first. And yeah, I haven't started testing locally actually. I was working on something else now, but my next plan is to testing connect to the local B2B network with the Etherspot bundler. Yeah.
So, Will, if you can, Sharif reported that he was having issues with snappy compression on the Gossip Sub interface from Skanda. So, if you're facing the same problem as well, do let us know. We'll continue to investigate from our side, but yeah, if you can let us know, that will be great.
Yeah. Okay.
Thank you.
Actually, if we disable the compression, it works. Like we was able to exchange user operations. So
Okay.
Yeah.
Thanks. So yeah, Dan, we defer to you.
Sweet. Just a quick update on where we're at. I have and you can, if you're interested, all the PRs are up on our Rundler open source, but nothing's merged. A super MVP implementation that at least incorporates disk v5 and the request response domain and the gossip domain. Doesn't do everything that you would need to do to like manage your peers correctly, but at least sends messages around. So yeah, in doing that, I kind of noticed a few things about the spec that I think are worth discussing and likely updating. So do we want to go through those now? Is that sweet? Cool. Okay, I will start with the gossip stuff, and we'll go from there. So currently, the way that gossip is defined, we have this message called user operations with entry point. And that contains entry point, verified at block hash, chain ID, and then a list of user operations. So the way that Gossip Sub works in libp2p, each message, well, then also in our spec, we define what the message ID should be for our topics. And the message ID is basically the SHA-256 hash of that entire object.
Yeah.
And so it incorporates that entire list of user operations right at the bottom of that request. That message ID is how the network, the Gossip Sub network, deduplicates messages across the Gossip mesh. So if there's two bundlers that have a slightly different list of user operations, they might include the same user operation. They might be in slightly different orders. It'll end up with a different message ID. And then you'll end up sending the user operations. So basically the way that Gossip Sub works is I'll notice that, hey, I don't have message ID 1 and this peer has message ID 1. I'll ask for it, and message ID, that message then might come back and have user ops 0, 1, and 2. If someone else sent me 2, 1, and 0, I would have to actually get both of those user ops twice. So
I'm thinking we're using one message for two purposes, because when a user operation is received by a node, it should propagate it. It should not batch it before propagating.
Yep.
The reason for using a batch is only for initial synchronization.
Yep.
Basically, so, the same. This should be two different messages.
Totally. Yeah. So I think the solution for Gossip Sub is to switch to a message type that is just a single user operation, and the block hash that it was verified at. We get slight inefficiencies because two bundlers might have verified at different block hashes.
Different blocks.
It's not terrible. It's only like a couple, maybe. Ideally it's not too many, and if you find a peer that's verifying at block hashes that are crazy, you can always disconnect that peer. I think actually internally Gossip Sub does do all the batching of message IDs for you. So like it will say to a peer, hey, I have messages 1, 2, and 3, and then you can say, hey, give me 2 and 3. So I think switching to, I think I called it just verified user operation, which is just those 2 fields, will massively improve the efficiency of the Gossip network.
Yeah. Can we even sort it maybe?
I mean, if you sort it, you still run into the same issue of like if someone has an extra 1 at the end, they would have a different message ID. So if you throw 10 user ops in the same message.
I hear you on the possibility of being, but just for the purpose to ensure that the user operations are not sent in random order, probably it's good to sort and then then send it over. It's just as an idea.
The sort solve only one problem of ordering, but it doesn't solve different views. It's either 2 type of messages. One sends single user op and the other is send a batch, or a convention like always saying a single user op unless someone asks you for a batch, and only then send the batch. But
but that will be part of request response anyway. It won't be part of Gossip. I
think different messages makes more sense.
Okay.
And again, Gossip Sub's implementation, the actual like protocol definition, does the batching for you.
Yeah.
So
Right.
Yep.
One comment on the ops not being likely verified in with different block hashes. I think that actually around the time of a new block, all the new ops around that time will probably be like 50%, like a 50% with the old block hash, 50% with the new one. So on Ethereum, the blocks are fairly slow, so it's fine. But for example, if you're on a network that produces a new block every second, I think that the majority of the user operations will be duplicated.
Yeah.
Actually, putting the block number as part of the message ID is not strictly required, because we added this block hash number in order to find the spammers. As long as people don't spam, this is not a problem. And adding this hash into the message ID will not prevent, will do nothing about spamming. It only break the message IDs, as you have said. So maybe it's better to remove the block hash number from this message ID.
Message ID. Okay.
Yeah, it said. I mean, you send it as part of the message, but it doesn't have to be the message ID.
Exactly. Exactly.
Yeah. The only issue there is that you can't. Well, no, actually, you're guaranteed because the peer who's forwarding you this message ID has to have verified that the message was that the user operation was valid before forwarding it to you. So it doesn't really matter what that message ID is, or what? Sorry, it doesn't really matter what that verified at block hash value is. We could just remove it from the message ID. Yeah,
I mean, it matters. No, it matters in order to determine whether someone is a spammer, but not as part of the message ID. If they send you a message with a block hash and it doesn't validate against this block hash, it's a spammer, but it's not in the message ID for that.
Yeah, that makes sense to me. I think the one caveat there is that if you do look at the ETH2 consensus spec, like the way that they define message IDs is always the hash of the entire message. I don't know if that was just for convenience and they didn't have this sort of thing in there, but I don't see any reason why we couldn't be able to say, hey, the message ID for the verified user operation is just the user operation portion.
Yes. The message ID is a hash over the message. The block hash is not part of the message. Is the metadata we added, it's not part of the message ID.
Yeah, okay. Makes sense to me. Any other thoughts on that? I think that's a kind of a change that we should look to make soon. Yeah. Because it does just fix basically the gossip network.
Yeah, I'll be pushing the updated spec anyway. There's one PR that's outstanding, which was I mean, I can push it as a part of the same thing.
Cool. Okay. While we're on the topic of message IDs, there is another message ID issue. So the way that Gossip Sub defines caching is based on message IDs, and they define caching on both the send and the receive side. So what at least the Rust and Go implementations do, I didn't look at the TypeScript implementation, JavaScript implementation, is if you try to send the same message ID twice on two separate topics, it actually will not send the second onto the second topic, which is good for network noise, but it breaks the issue where you have a UO that matches two different alternative mempools and separate peers for each of those mempools. You actually can't send it to the second set of peers. It gets deduplicated by the protocol.
I thought, so let's take a scenario. You have a bundler A and bundler B. Bundler A supports two mempools. Bundler B supports only the second mempool. Bundler A would notify bundler B both the user op that would satisfy two mempools, right? Anyway, because that's how it should be. But assuming bundler B supports both the mempool, it would have received the message only once.
That's correct, but let's introduce bundler C now. So now you've got bundler A that supports, and let's leave the canonical mempool out. Let's just say it's alternative mempools. Bundler A, which supports mempools 1 and 2. Bundler B, which supports mempool 1, and bundler C, which supports mempool 2.
Yep.
You got a user operation that matches some two alternative mempools. It fits into both of the rule sets. I don't know is that a possibility, Dror? Like that if a particular user operation matches two alternative mempools.
Look, it depends what we call an alternative mempool, because beginning when we started, alternative mempool was a complete wildcard saying anything that we want to add in the future, let's have a wildcard that will support it. So by the current definition, yes, it is possible. Maybe we need to strict down what alternative mempool can be, and then
I don't think we should. It's I mean, even if you define, I know you've been working on definition. Both of you have been working on different ways of defining alt mempools, but I think that's what it should be. It should be alt. It should be, there could be other alternatives in the future. People will come up with more ways of defining it. So I don't think we should place restrictions on what the rules of an alt mempool should look like. We can, for convenience, we can have definitions, but I don't think we should make one. And
so technically, you can have all the possible combination between different mempools.
Yeah.
Could be mempool GNC, and some user op is valid in any combination of these.
Okay.
Yeah,
so let's.
And it's very likely that you'll have user ops. I mean, first of all, every user op that matches an alt mempool also, that matches the canonical also matches every alt mempool. So you already have this, and it's quite likely that you'll have ones that match multiple definitions, because there will be partial overlap with the rules.
Okay, so let's say, go back to the example. Let's say bundler. Let's say this user operation that we simulate matches mempools 1 and 2. And again, bundlers B has mempool 1, C has mempool 2. I send the user operation to B, or I actually gossip the user operation to B, right? So I put it into gossip sub. When I try to put it onto the mempool 2's topic and send it onto that topic, libp2p will drop the message because I've already sent it on another topic.
That's right. Yeah.
So bundler C never gets the user operation.
But bundler C would have received it from bundler 1, won't it? Because bundler 1 supports both the topics.
Correct, but that's the problem, is bundler 1 can't send it on the second topic because libp2p deduplicates it.
I thought it is this validation is per peer basis, right? Not necessarily.
No, it's actually global on it's across topics. So like when I say like literally the publish command, like the publish SDK function has a cache in it, and if you try to publish the same message ID twice, it just will drop the second send.
But there is another implementation within libp2p, which I forget the term, where instead of I have things are queried, and there is a possibility that you can still receive a message on a topic that you're not subscribed to. So isn't that redundancy built into libp2p? I forget the exact term.
You're talking about receiving. What Dan says is that there is a global cache by message ID. You send by topic, but message ID is not part of the topic. So
no, I understand. What I'm saying is, because bundler 2 has already received that message for that topic, because bundler 3 is connected to bundler 2, it would eventually receive the message even though it's not subscribed to the topic 1. I remember reading it sometime back in libp2p documentation.
I don't believe that's the case.
So then, just if I understand correctly, the issue is that you can't that we have the duplication, but it's not done per peer, but globally. So how about why not include the peer you are sending to as part of the message ID? So like for each peer you generate a different one. Now it gets deduplicated, so you get a desired behavior.
But you're not sending to peer. The message.
No. So what we should do that's on what I'm recommending that we do that's on similar to that is you put the topic in the message ID. So you do topic plus hash, and you hash that.
But then
but then you, okay, let's say we have topic A and B and C, and the bundlers are bundler A, bundler B, and bundler AB. Now, I am some bundler, I receive the user op, and it's a user op is valid for mempools A and B. So I want to send it once to A and B. I'm trying to understand who will not receive it. I'm sending it once.
So it's not that you're sending it twice because it's matched two different mempools, right? It's matched topic, it's matched mempool topic, which is a different gossip subtopic, and you want to send it to a different set of peers that you've maintained for each of these mempools.
Yes, because Yoav, if I put the topic as part of the message, I will send it the number of mempools I'm in.
So
correct.
But then
actually, there are two kinds of peers each node is connected to. One is a full peer and the other is a metadata only peer. With full peer, you exchange or gossip topics that both peers are subscribed to. For metadata peer, you publish everything irrespective of whether they are subscribed to or not. And this is how libp2p manages to achieve redundancy by ensuring that when a particular peer is not a full peer, that is a metadata only peer, you can still continue to request messages specific to a particular topic ID by just passing that particular information. That's my understanding of the documentation given there in this space.
That doesn't solve the problem because, again, I'm on topic 2. libp2p won't even say that I have this message on topic 2. It will say you've already sent this message before on another topic.
Yes.
And it just drops it. It's like the first thing that it checks in the publish command is like, have you sent this message? And it says, oh, you have, not doing anything with it.
Yeah. No, I understand the problem. It is a problem. If it's if the duplication is global, then some mempool will not receive the message because you are connected to peers with different alt mempools. So yeah, it is a problem. We need to figure it out. But I'm not sure. I mean, if we add the topic to it, then we lose the duplication entirely. It means that in anything like most of the user ops which actually match the alt mempool will also match every. It matches the canonical. They also match every alt mempool because they only add exceptions. They don't remove any rules. So it means that most of the user ops will actually be sent on every topic. So that's not we lose the duplication entirely, and the network is going to be flooded. So, but I'm still not sure I understand why can't we include why can't we send a message to a particular peer by adding the peer to the message ID, like add it for every peer that you're connected to.
That would work, but it floods the network because each UO that you try to send to a particular peer by message ID will look to gossip sub just like a different message, and every peer would receive every message that's meant for other peers because in gossip sub there's no like direct send.
You're doing direct messaging and not pub sub.
Yes. Yeah, that's correct.
Yeah. So one potential thought here is that if a user operation matches the canonical mempool, and we can define what canonical is, basically you only send it on the canonical topic. You don't send it to any of the alt mempools. And if a user wants to receive canonical mempool user operations, they have to be subscribed to that. If it doesn't match the canonical mempool, say it again.
No, I thought it was mandatory for every bundler to support the canonical mempool.
Okay, you give a special treatment to canonical.
Oh.
But let's continue.
I'm not sure.
Try to avoid it. Let's finish it. Let's hear.
There is
sorry.
No, but I'm not sure we can define it this way. I mean, let's say.
Just a second.
Just let me add one comment. One comment because it might change the story. let me give one example, and let me know if this example, if it can still cover it. Let's say, take USDC, take Circle's alt mempool. So it can never be the canonical mempool because it makes an exception for a specific contract. But it's very likely that close to 100% of the bundlers will be a part of this, and that every user operation is going to match it. So whatever solution works should take this into account.
Okay.
Right. So let's see if we can design around that.
Yeah. The thought was that canonical mempool special treatment, you only send it on that. After the canonical mempool, you would send it, if it doesn't match the canonical mempool, you send it on each alternative mempool that it matches. So if a bundler is subscribed to n alternative mempools, there is, in maybe some crazy case, if some user operation matches all of their mempools, they might get it n times. But if they're subscribed to discrete mempools, like each alternative mempool supports kind of rules that don't have a lot of overlap. In this case, where a user operation matches multiple is pretty rare, the bundler will only receive that user operation once, maybe twice sometimes, and then should have its own internal deduplication. It's really not that big of a deal to be gossiping like extra message IDs around the network. They can get gossiped all over the place. It's just when you want to, you want to receive a new message, you pull it back and you say, hey, like, have I actually seen this user operation after you actually receive it? Does that make sense? Trying to think through it.
Yeah, we could optimize it this way, but I think in this case, they're actually, it's a bit counterintuitive when you're using the word canonical, because you'll probably have to have a flag for each mempool saying whether this is a canonical mempool or not, and the reason is multiple entry points. For example, if you have, if we are transitioning from an old entry point to a new one, you have a canonical for each of them at the same time during the transition, which could be a long time. So for both of them, you want to have the spatial behavior. You consider both of them canonical, and if it doesn't match any of them, then you use then you switch to propagating to every that matches.
We once had an idea which we tried to drop, which is a message ID for any combination of mempools, which because it will grow exponentially. If you have 3 mempools, all the combination, I think there are 8. So it is problematic to join. If you want to join these 3, you have to join all 8 combinations. So I don't think it's a good idea. But
no, it would explode as soon as we have
of course.
the parameterized mempools that you've been working on.
It's exponential. It's bad. The other option, I'm not sure whether it's possible, is to have a version of the libp2p that caches by message last topic.
Yep.
If you cache by that, then yes, it's a dedicated version for us. Actually, not that much of a problem, because I don't think they use that many topics. You might say, abuse the term topic. And they haven't think about this combination of sending message to multiple mempools.
So I asked this question in the libp2p forum and haven't gotten any responses back. I don't know if anyone is close to anyone or knows anyone who knows someone who's a libp2p architect. I would love to have that conversation. Is that exactly what Dror said? I wonder if that's something that is just something as a use case they haven't run into, but just on the scene side, or sorry, on the send side cache, in my mind, it just makes sense that for that to be per topic, so that you can propagate a message ID on multiple topics.
How many topics are on the Ethereum?
Ethereum has quite a few, right? Around 10, maybe. I don't know.
but for different type of messages.
Yeah.
So they don't have the problem. So again,
Yeah, it's
I mean,
our problem is very specific.
Yeah. So Danny Ryan put me in touch with a few guys at libp2p. So Dan, I'll probably add you to that group. We can take this forward with them. They should be able to help us out.
Yeah, that'd be great. I think, assuming that they're not okay with that, if they don't want to add that in, there's two options. Either each bundler can fork libp2p themselves, which is a little bit annoying. And then the second option, I think, is just to make alternative mempools work, is we have to put the topic into the message ID, and then it does allow for slight duplication. And then I think we need to figure out if we want to have this special casing for a canonically tagged mempool.
Another option with libp2p is to push a PR that give an optional flag in that cache by mempool. So if you think global cache is a good idea, I don't care if that would be the default. I just want the alternative to cache by topic.
Cache by topic, yeah, I agree. That would solve the problem entirely.
Yeah, but acceptance of that PR is gonna take much longer than we expect. So we'd be using an unstable version of libp2p.
We will maintain fork library.
And maintain how many different implementations: JavaScript, Rust, Python, Go as well. So I mean, that's fine.
It's implementing for each implementation. It's meaning that the index of the cache is hashing one more field. The question is it a problem to propagate it into the cache? It could be that currently it doesn't see the topic.
It seems reasonable to me.
Of course, yeah. The one that you were talking of, Dror, earlier was to, what do you say, concatenate each, mempool ID as a part of the topic, message ID. Was that the case? Or are you referring to a keycache or a Merkle tree hash of each and add that as probably a part of the message ID?
No, we can't put it as part of the message ID. The whole idea is that we want to be able to send the same message ID over multiple topics. So changing the message ID will not solve the problem. We want the same message ID. We only want the caching.
Okay. I get you. Yeah, thank you.
For us, this caching is premature optimization. But okay, it's good for the use case, but we have a slightly different use case.
Yep, agreed. Cool. All right. Well, let's take that up with the libp2p team and see if we can get it optimized, or just add our own forks.
You have any contact with them? Personal contact?
Oh yeah, Yoav put me in touch with certain team members of libp2p, and I'll add Dan to that, and we can take the discussion forward.
Great. Cool. I think the next most important thing to discuss is discovery, specifically alt mempool peer discovery. So one of the things that's going to be important over time, or important for bundlers to do to maintain the health of alternative mempools, will be to maintain at least some n. It'll be a configuration variable, but something like 6, 8, 12 peers per mempool that they're subscribed to, so that they can make sure that they have a diverse set of peers and receive user operations on those alternative mempools. Obviously, you can make optimizations if you find a peer that supports both and that it fits in both buckets. Would be great. So for things like the USDC mempool, where everybody supports it, you won't necessarily need to maintain 16 peers. If you want 8 and 8, you could just have 8, because hopefully they all support both. Okay, so for the more obscure alternative mempools that are maybe just starting up or less people support, we need a way to discover peers that support that mempool. And as defined right now, there's nothing in the spec that lets us kind of improve the process. basically what we would do is just say, currently the status quo is you learn about any bundler that supports 437 via DISV5, and you get their ENR. That gives you connection information. You ping, you start connecting to them. Eventually you receive the mempools that they support, and then you have to decide at that point whether or not to drop. So you're going to end up with a lot of these, like, if you're trying to find a particular user that supports a particular mempool, you're going to end up with a lot of these like dials that end up getting quickly dropped because they don't support the mempool that you want. So while that works, it's pretty inefficient. So one of the things that's in the ETH2 spec is, and this is very different than our case, but the ETH2 spec has this idea of subnets where each validator chooses a subnet to be in, so they're only receiving a subset of the attestations, I believe. I'm probably botching that description, but there is some way to segment the network into a bunch of subnets. And that gets when a validator wants to join a subnet, that actually becomes part of their discovery process. They actually find other validators that are on their subnet using ENRs. So in our existing ENR, we have a mempool subnet field, but we don't describe how that can be used. It's kind of just there, and it's not described how that could be used to actually find other peers that support your alternative mempool. Unfortunately, ENRs are maximum 300 bytes. So you can't just like put in your ENR. I mean, maybe you could, but eventually we'll run into the issue where someone wants to support more mempools that can go in an ENR. So we have to either come up with a way to do this outside of DISV5 without ENRs, or with having like segmented boot nodes or segmented hash tables somehow. I don't really know exactly how that would work. Or we add extra information to the ENR to try to improve this process. So I threw a suggestion. To be honest, I haven't thought it all the way through, with the idea that we segment the network into, well, not the network, but you segment alternative mempools into buckets, basically. You say, hey, we're going to have 1024 buckets. And you just take the mempool ID mod number of buckets, and if you support a mempool in that bucket, you have that bit set in your ENR, and then that at least will improve the random dialing to at least by at least a factor of the number of buckets that we support. I think we can support a large number of buckets if we use SSE, and if we come up with a very sparse bit set implementation of that, we could probably support it, depending on what we think the maximum number of mempools a particular bundler will want to subscribe to. We could probably support on the order of 16,000 or something like that. I don't know. Any thoughts on that so far?
So yeah, I think it makes perfect sense. It's and we don't need to solve it. It's something that we ignored, and the proposal with the buckets sound like a reasonable way to support it. Just wanted to understand if it's if you are in a certain bucket, you're going to allocate a part of your peers to a part of your pool of peers to it, or you're going to try to to get as many of them as you can. It's because we also don't want to have clicks small clicks in the network. You want to have at least some that are not in your bucket. But otherwise, I think it makes sense.
Yeah, maybe set up a separate threshold which says minimum of X number of peers should be a part of the bucket, and no more than that.
The point is that we're using. Sorry, I don't know enough libp2p, but it's a decentralized pub/sub mechanism. And what we are saying, hey, I need a mechanism to find who else is subscribed to this topic. It seems like, and we try to create a custom solution for that. And it seemed like a generic problem of a decentralized pub/sub mechanism. So either they didn't solve the problem how to find the subscription, because maybe they didn't have to. Maybe LP2P was born in a case where the amount of topics is small and known, and there is no need. It's okay to broadcast to everything or something. But I think better research to find a generic solution, because we're trying to find, instead of trying to tailor a specific solution for this problem.
I believe if the subnet ID can be computed using fork, something like that, like in the case of the consensus protocol. Yeah, so this is maybe how they are computing it.
Well, yeah, they find subnet ID and then use disk v5 ENRs to filter by. They discover all the ENRs and then they filter by users that support that subnet ID, and then they dial them and add them to their gossip protocol. I think it's possible. I haven't actually looked. So libp2p does ship with a different distributed hash table discovery that we don't use because we're Ethereum and we're using disk v5. I don't know if they've tried to solve that problem drawer. I haven't really looked into the discovery that they use. I don't believe there's any sort of discovery that is part of Gossip Sub. You have to find peers through some sort of other mechanism, dial them, and then they get that you negotiate which topics that you support.
So your bucket mechanism seems perfectly sense, like reducing to 10% of nodes to check seems like a reasonable trade-off. But again, it assumes something about the size of the network.
Mm. Okay. Probably worth a little bit more research just to see if there is some other solution to this that we haven't researched. Again, I kind of just realized that there was no way that for me to discover peers of my mempool and kind of threw a proposal in there without doing much research. But the bucket stuff might work, and I think it might also make sense to look at a data structure that does this sparse bit vector stuff, because I don't think bundlers will be supporting hundreds of mempools. They'll be supporting tens of mempools. And so if you have but there might be thousands of mempools defined across the network. And if you allow for 10,000 buckets and you only support 10 of them, storing a bit for every bucket is ridiculous because you're just storing mostly zeros. So you can compress that down to something a lot smaller and just store the non-zero bytes. But we would need to define that data structure. That's not something that's like an SSZ bit vector support. We would have to write our own spec for that data structure.
Yes. My problem is we try to optimize and build a structure for something that I don't want ever to happen. Like alt mempools exist to support a non-standard environment, but the reason for the mempools and rules, even though they're annoying, is to protect the network. Nobody still tried, I believe, to attack a network, to attack specific bundlers. There's no, and they're not currently not protected. There is no mempool. There's no. But once there will be I think it will be very hard to deviate from that to create that many mempools. So I don't. Maybe I'm trying to think. Maybe chains will think they have their own great solution specific for their own chain. So you will have number of mempools proportional to the number of chains, like tens of mempools, I don't think they're going to be 10,000. And for that matter, I don't think that we should try to support any application to decide, hey, I want to bring up my own bundler, I want to bring up my own mempool. You want to bring up your own bundler, go ahead, bring up your own bundler, but then you are a single bundler. You don't need a mempool. For that matter, drop the validation altogether. I don't care. So it's not something we need to optimize for these huge numbers.
Yeah, that makes sense. So
a bit vector with compression, it perfectly makes sense. Yes, but not
necessary.
Over engineering unless you think of a use case that will be useful.
That makes sense to me. So I mean, we could just say, hey, we're going to choose, 1K buckets. That's 128 bits, or sorry, 128 bytes of the ENR would be dedicated to that bit vector. We can even go smaller. You could say we're going to support, just 16 bytes of bit vector for these buckets.
As I said, even something like compressing down zero-length encoding of this bit vector, sparse vector of 1,000 seemed like a balance. I didn't look at the numbers, how much it will size, but it's well contained. It is optimized, but it is well contained. Not something grander than this. Again, this is the way I see it, unless you think there is a reason to support such a large number. There is a use case for that. Because we don't want to encourage that too much. Yoav, what do you think about it?
I think I need to think about it some more. It's a problem. It's a problem that I haven't thought about till now, so I want to think about it a bit.
Cool. Well, let's take it offline then. Think about just discovery in general, how to improve the discovery process of alternative mempool peers.
Yeah, even with the buckets idea, when you combine it with a large number of generated alt mempools, such as when using a parameterized rule, then you might end up being a member of so many of them that it would become ineffective to use this method. So I'm trying to think around that.
Look, we can always, if there's a large number, let's say that some people find out they need a private mempool. Okay, like a very small one for this specific project, and we see like thousands of such small mempools. But then again, most bundlers don't support them. So every bundler supports a very small number. And now there comes a bundler that needs to support multiple mempools, and this multiple becomes large so that reporting these bits becomes big. It means probably that these tiny mempools become more important, and maybe they can join together, and they're going to be defined mempool that says this mempool is the combination of these 10 mempools. It's this one instead of these other 10.
Now, the case I have in mind is the parameterized case we talked about where the rule is identical except for the token. You have a rule for paymasters. You have a rule for token paymasters where you allow a token to do approvals. Now, it can't be one big mempool for all the tokens because they can poison each other. We discussed these attacks. So since they have to be separate ones and there are a lot of tokens, each token. So the rule itself is written in a parameterized way, but then but at the mempool, at the alt mempool level, you have a separate alt mempool for each token. It happens automatically, but the definition creates multiple mempools. But now every token will generate another one, and the bucket, and you'll have a lot of buckets, and all of them are. It's not a small subset that is only used by some users. Some of these tokens are very popular, and you want to have a big mempool for it.
Cool. Well, let's take the rest of the discovery stuff for the next meeting. Last couple things, these are a little bit smaller, are related to the request response domain. The first one is, I think we should move this like supported mempools into the metadata. So actually the part of the like little, it's like actually the way that it gets implemented is it actually typically gets persisted on disk. Of like, hey, these are the mempools you support. This is my sequence number, whatever other metadata you might want to throw in there. It's probably just going to be that for now. And then in your pinging, when you're just like checking in on a peer, that if that's metadata changes, the sequence number changes, and then you request the full metadata. It's just more in line with how the ETH2 implementation works, and there's no need to just consistently send back and forth all of the mempools you support. You just request it when you need it, typically just on startup or just on initial peer negotiation. Yep. I think that one is
for the map, but again, putting a change and putting the map in the metadata, and the action is simpler.
Yep. And then the last one is regards to the pooled user op hashes and pooled user ops by hash. The offset list, I think we've discussed this before, but when I went back to it, I got a little bit confused, and I think we might need to define a little bit more about how that offset list is meant to work. I remember Dror saying having a proposal on this, but one of the things that it doesn't make sense to me to indefinitely support some offset into some list for a particular peer for a particular amount of time. So a peer requests user ops and you send 4K back and you've got more. How long do they have to ask for more before?
If the context of batch requests should be defined in a way.
Yep, exactly. And I have a proposal in there, which is like some time-based thing where it times out, but we do need some definition of how to define the scope of that context. And then in general, actually, with that pooling stuff, I'm curious what people's thoughts are on its usefulness, especially on L2s, where block times are in the 2 seconds. It seems to me like just subscribing to the Gossip Network, like within 10 seconds, you'll have enough user ops in your mempool to be competitive with all other bundlers. So in my mind, this pooled stuff is, while it might be a nice optimization to save bundlers like 10 seconds on startup to get some initial user ops, at least for these networks that have faster block times, I don't really see its use on fast block time networks. Maybe it makes sense on Ethereum with its 12-second block time, but again, like you just wait, you start your bundler up, which you shouldn't be doing that often. You wait a minute and it's ready to go. So I'm curious, kind of, I understand Ethereum Dev P2P has this functionality, but to me, it doesn't seem super useful. I don't know if there's any thoughts on that.
I mean, the protocol is being defined for Ethereum, right? Not necessarily for L2. So we should have it there anyway. Whether a bundler chooses to implement it on the L2 or not is probably a bundler's call.
Another small issue for this feature is for testing purposes. If I want to check your bundler to see whether it works correctly with the P2P, I need a way to query your mempool to see what you have. Even for that purpose, yes, I agree that for production, it becomes useful only for the first seconds. It means that it is perfectly okay to take a bundler down and restart it, and you will lose nothing. So if you want to do it periodically or whatever, you don't lose time, and for testing purposes. And for production, you're right. It's the usefulness is limited.
Yeah. Okay.
Why do you
Well,
think?
if
Do you think it's problematic for implementation-wise?
the only thing was the offset list stuff.
Yes,
that was a little weird.
Yes, I agree with you. There is a need for timeout for that, and for that purpose, if your bundler define, or even whether it's a protocol definition or a bundler specific definition, like I don't want to keep. If you want to ask me, I will return you only the first 4K, because the timeout they give is 0 seconds. Next time you ask, you will get the list right from the beginning. I don't return any more than 4K out of my mempool. Might be good enough because I don't want to cache anything for other to query.
Yeah. That was the only kind of complication there that I was like, and also, you know, where this is going to be used today is on these fast block time L2s, where it's not going to be useful. Yeah.
On testing, we will have it for debugging, right? So the code is there. The question is, should we call debug only, or is it we call it a required API?
Cool. Yeah, I don't mind implementing it just with more information on that context side of things. But sorry, the offset lists. Cool. I think we got through the majority of that doc.
I saw your comment on that. Did you have a PR on that? Or did I see it?
No, it was a separate linked document. This is the one, Dror. Where is it? Yeah.
Okay.
Oh, sorry, Dror. Have you not seen this doc yet? I was basically reading from this doc for the whole meeting. Cool. So it seems like we've got a couple things to follow up on: the discovery stuff, the libp2p stuff with the gossip sub deduplication. Just an FYI, I'm out for the next 2 weeks. So I will be ready to work on this again after that. So in the meantime, well, I'm going to be on my honeymoon, so I likely won't be catching up too much on this stuff. So I will catch up with you guys 2 weeks from now.
Okay.
A little bit more. Well, so I won't be at the next meeting, so I'll miss the next meeting.
All right, then congratulations.
Thank you. Thank you. All right.
Any other questions from anyone?
Are you going to be DevConnect?
Likely. That is our plan at the moment.
Okay. Good luck with that too.
Okay, then.
Is your plan to be there, Dror, Yoav, Martha?
Well, I'm not sure there are flights.
Yeah.
For now, there are no flights. There are no flights here, so we don't know.
Okay.
Especially not for Turkey.
Yeah.
Okay, then. Cheers. Have a nice day. Speak to you later. Thank you.
Bye.
Bye.
Bye. Take care.